All right, so we're going to go over some kind of nifty, a little bit confusing at first stuff called cause and effect, chaos theory, the butterfly effect, and a little bit more. So buckle your seatbelts and go into this with an open mind. All right, so cause and effect, simple enough, right? Cause and effect is a relationship between events or things where one is the result of the other or others. So cause is the thing that makes other things happen. Think of the phrase because, right? And then the effect refers to what happens because of the cause, due to the cause. So if you look at the bottom, we've got right here, if this were to hit those, they would all swing. So the cause is the ball hitting them, and the effect is them all swinging. Right over here, we've got cause, which is the why. So it started raining. What happened is the effect. So you needed an umbrella. So you needed an umbrella because it started raining. So again, cause is the reason for something happening, and the effect is what happened. Cause and effect explain why things happen. So some signal words that help you identify cause and effect are so, because, therefore, since, if, then, so that, without, cause, effect, how, and explain. So now it's going to get a little bit more confusing, but bear with me here, okay? So chaos theory. Chaos theory is a part of mathematics. So it looks at certain systems that are very sensitive, and a very small change may make the system behave completely differently. So some systems, like weather systems, might appear random at first look, but chaos theory says that these kinds of systems or patterns may not be as random as we think. Chaos theory states that within the randomness of chaotic and complex systems, there are underlying patterns, there's interconnectedness, constant feedback loops, repetition, fractals, and self-organization.
See, the Tyrannosaur doesn't obey any set patterns or park schedules. It's the essence of chaos.
I'm still not clear on chaos.
It simply deals with predictability in complex systems. The shorthand is the butterfly effect. A butterfly can flap its wings in Peking, and in Central Park you get rain instead of sunshine.
Why?
And did I go too fast? I go too fast. I did a flyby. No, give me that big glass of water. We're going to conduct an experiment. It should be still. The car's bouncing up and down, but that's okay. It's just an example. Now, put your hand flat like a hieroglyphic. Now, let's say a drop of water falls in your hand. Which way is the drop going to roll off? Over which finger, or over the thumb, or the other side?
Thumb. That's it.
Okay.
Right.
Okay, now freeze your hand. Don't move. I'm going to do the same thing. Start with the same place again. Which way is it going to roll off, do you think?
Let's say back. Same way.
Same way? Same back? It changed. Why? Because tiny variations, the orientation of the hairs on your hands.
Hey, Ellen, look at this.
The amount of blood descending your vessels, imperfections in the skin.
Imperfections in your skin?
Microscopic, and never repeat and vastly affect the outcome. That's what?
Unpredictability.
Huh? There. Look at this. See? I'm right again. Nobody could have predicted that Dr. Grant would suddenly jump out of a moving vehicle.
Alan!
There's another example. See, here I am now by myself, talking to myself. That's chaos theory.
So that was an example from Jurassic Park where he talks about chaos theory. So he talks about how small variations can cause differences in the patterns that we see. So things aren't as predictable as you might think, and small actions can have consequences or different results. So we're going to talk about the butterfly effect, which is also a movie, and here's the title slide from that movie. It has been said that something as small as the flutter of a butterfly's wing can ultimately cause a typhoon halfway around the world. So that's an explanation of chaos theory. So basically what that's saying is that something as small as, say, a butterfly flapping its wing could cause a chain of events that ultimately leads to something even bigger, like a typhoon happening halfway around the world. So I know that's a lot. So what is the butterfly effect? The butterfly effect is an idea that is more commonly used in chaos theory. The theory states that a small change can make much bigger changes happen. One small incident can have a big impact on the future. So the term comes from an analogy where a butterfly flaps its wings in, say, Chicago, and then a tornado occurs in Tokyo, right? This is fitting for the story we're about to read, A Sound of Thunder. Many people attribute the origin of the phrase to this story, although it is untrue.
Chaos theory, the butterfly effect. What are these things really? Hey there, future internet users. I've been Trace, and I will hopefully still be him in the future, and this is probably still D-News. We're gonna see. You've probably heard about the butterfly effect, usually explained by the idea that a butterfly flaps its wings in Brazil and causes a hurricane in Texas. Premise ridiculous. Of course they cannot do that. There are millions of butterflies. If everyone caused the beginnings of a storm, Earth would be in chaos. The thing is, that's not really what the butterfly effect is about. It's about how tiny changes in big systems can have complex results. Systems in this case could be anything from weather patterns to how big groups of asteroids move to how lots of people interact. For an example of a system, picture a tilt-a-whirl ride at a carnival. If you don't know what that is, it's a rotating and shifting platform with shell-like cars, each rotating on a smaller circle with people in them. It has rules, and it follows those rules rigidly. The platform rotates the same every time, and the carts can only rotate around specific points. By analyzing this, you can see the butterfly effect in action. If I, say, sat alone in one of the tilt-a-whirl carts, it would spin completely differently than if you sat in there with me, right? Together, we would be heavier, and the cart would have a completely different ride. Every spin would be completely different from when I took the ride alone, and unpredictably. Now imagine all the carts as part of a system, with tiny changes to each, someone being a little lighter or heavier in a cart, someone sitting forward on the seat or with their back on the wall. All of these tiny variations affect the whole tilt-a-whirl system. That's the butterfly effect, which does have a scientific name, sensitive dependence on initial conditions. This was originally discovered by an MIT mathematician and meteorologist, Edward Lorenz, who was using an old computer to calculate weather patterns. He ran a simulation and wanted to see it again. The first time, he put the data into 6 decimal places, but figured the second time those tiny fractions of a degree wouldn't matter, so he only used 3 decimal places. In the end, because he cut out just those few fractions of a fraction, the whole simulation completely changed. It was unrecognizable the second time. At the time, mathematicians thought if you changed a little at the start, it would only change a little at the end. That was logical. But these systems don't behave that way, and we needed new math to understand why. In walks chaos theory. Chaos theory, by definition, deals with the complex systems whose behavior is highly sensitive to slight changes in conditions. It appears to be chaos, but it's actually governed by the same rules as everything else in nature, physics, and the universe. But because there are so many moving parts, it's just impossible for us to comprehend them all. Imagine watching all the people get on the tilt-a-whirl and then guessing how every card is going to move. No way. Chaos theory was groundbreaking when it was discovered because it threw off classical physics. Isaac Newton's laws of nature, equal and opposite reactions and such, were all imagined in a clockwork universe. A little change here and a little change at the end. Not one filled with apparent chaos. Basically, he thought if we could understand the basic rules of the universe, we should understand everything in the universe too, which seems wrong. Because even a tiny change in something with as many moving parts as the universe would mean any assumptions we made would be astronomically wrong. And that's super scary. We went from grasping a good chunk of our universe to who knows where. But the universe is not random. It's governed by rules. Rules which mathematicians have worked on understanding for centuries. Take nature, for example. It might seem random, but it's governed by rules, and that's why it makes shapes like this. These are called fractals, and they show us how chaos is really order. It's an infinitely complex, repeating pattern that can appear chaotic at times, but is actually ordered. Chaos theory is an attempt to approximate and understand all the people getting on a tilt-a-whirl and how the tilt-a-whirl will then react to their actions, thus finding order in the chaos. So when you think of the butterfly effect, what should you think of? Understanding order from chaos. The original model Lorenz was working on appeared to spit out chaos until they graphed it, and then it looked like this. It looks like a butterfly.
The butterfly effect is a theory according to which the smallest thing, such as a butterfly flapping its wings, can create a series of events leading to a catastrophe, such as a tornado.
How does that work?
Like this. But more complicated. Now, I want you all to gather around my desk and witness the true beauty of nature as the butterfly emerges from its chrysalis. And I'm off the clock and don't have to pretend to care about your education. Coffee break. The baby is coming! Someone call 911!
Calm down! We need some towels and hot water!
Of course! I'll be right back!
You're right. Nothing better than a hot towel. No, for you! For him!
What would he want to do with hot water and towels?
I don't know!
He's coming! Okay, you breathe like this.
I think he wants to get out.
But what about the butterfly effect?
Dude, how could something this cute be responsible for something as bad as a tornado? It's like blaming baby boomers for the state of the world. How could babies going boom ruin the economy? Isn't nature beautiful?
Here we go, buddy. Cream with 2 sugars, just as sweet as you are.
Thanks, buddy. Oh, man, I'm sorry.
No. It's my fault. I just don't realize my own strength sometimes. Just this morning, I pat my son on the head. He went straight through the floor.
Whoa, is he okay?
Yeah. He called us from China. He's getting the next flight home.
Get it off! Get it off! Get it off!
Okay, buddy, don't worry. I'm just gonna push it off. I don't want to damage its beautiful wings. Jeepers, I'm sorry, man. Let me help you up.
Don't worry. It's nothing. Oh, man. I'm so sorry. Hold on. Oh, man. Here.
Don't worry. It's just a flesh wound.
Let me give you a hand.
Thanks. Sorry!
It's nothing. Hi, Bobby. Tell your mother I'll be home late for dinner.
Hey, get off the road! I gotta get to work, man!
I don't care. I have all the time in the world. I'm retired.
Looks like you needed a shower!
Would you like a ride?
Thank you, sir.
Well, at least you got closer to your destination.
Darn you, Robinson! I hope someday you get with these guys!
Ow!
Whoa! I wish I was rich! $20? Is that the best you can do?
So if you notice that one, not only did they explain the butterfly effect initially, and in a silly way as well, they also showed you that how one small action, so them letting the butterfly loose, caused that entire sequence of events. So that butterfly flapped its wings, flew out, right? And then the 2 construction workers got into that whole scuffle with the butterfly, and then his head popped off, and then you saw the kid coming back from China, so it was all connected. And then the head fell down and caused that whole karmic situation at the end. So in the short story we're about to read, A Sound of Thunder by Ray Bradbury, we get to see firsthand the effects our actions have. So think about all that you've learned during this PowerPoint, I know it's a lot, and ask yourself this question: how much impact do our actions have, even the small ones?